Okay, let's come back and move on the class, okay? Okay, after knowing what the data science is and the reason why we have the data science, these new fields, because most of you are in computer science department, I think. So I would like to introduce the difference between the data science and the computer science, okay? So that would be easier for you to face the new area, okay? The first thing is that we need to appreciate data. For the data science, the data is the data will be the major role, okay? And we need the data to have something new, so we need to appreciate the data, okay? But for the computer engineer, we usually do not care about the data, okay? We just have the program to run the data, okay? We don't care about what the data, what's inside the data, what kind of information we get from the data. We just have the program, we just feed the program using the data and get the output, and that's it. That would be the programmer, okay? But now things will be different because we need to abstract, we need to extract the information from the data, okay? So in addition to have the program to run things, we still need some technique that can help us to find the things inside the data, okay? So we need to appreciate the data, okay? Okay, so for the programmer, we just simply implement the algorithms, and that's it. If the input can be fitted into the program, then we get the output correctly. So we are done, right? So everything's done. That is for the computer scientist. Okay. But for the data science, in addition to that, we still need some ways to look at the details about the data set. Okay, and that means we need more work, and we also need to think about something when we have the new data set. Not only to run it, to process directly, okay? All right, so the other difference between the computer science and the real science, okay, there's a difference. And the real science is the scientist is trying to understand the complicated and messy world. But for the computer scientist, we usually have our own virtual world, okay? So that would be the difference, okay? We try to make our own world, okay? So that would be the computer scientist. Okay, and in computer scientist, we look at things in two different results, true or false. Okay, but in real life, there could be more possibilities. Okay. So nothing is ever completely true or false in science. Okay, so this will be different. We look at things in a binary format. Everything will be right or wrong, okay? All right, so this would be the differences, and there will be the difference of the culture, okay, between the computer and the real science, okay? And for the scientist, he would do the real science, so it would be the data-driven, okay? You will see a lot of scientists. They try to find out new things using data. And the computer scientists actually what we mentioned is algorithm-driven. We just need to know the process. We can implement the process in program, and that's it. Okay, and okay, the scientist is actually trying to explore the new things, discover new things. But the computer scientists try just simply invent, not discovered. Okay, just invent. Okay, so that means the computer scientists should be more enthusiasm, okay, on the things. And the other thing is very important because the computer scientist, in computer science, we look at things in 0 and 1, true or false. Okay, so we'll not allow the errors. We do not like errors. Okay, but in the real science, everything has some errors. Okay, so that will be different. All right, so because most of you are from the computer science department, so I think you are in the culture already. So now, if you look at things, you need to think more, not only true or false. Okay, it could be something with errors. Okay, so now you need to think things like a real scientist. All right, so the data now you get not only just fit into the program, you just look at you need to also look at the what the data inside, what the information inside the data set. Okay, so you may turn the numbers into some inside findings. Okay, and you need to know why instead of how. Okay, most of the time we just do the coding. We just code how to program, how to solve the problem. But in order to do the data science, you must have ask yourself the reason why. Okay, in many cases, if you look at the results after you experiment, know the reason why you can have such results. Okay, you need to think why. Okay, so that would be the difference. Okay. So the data now is not only simply digits and numbers. You need to find out some patterns among the data or something in the data. Okay, so the other things to talk about is how to have the findings. How to have the findings. In tradition, we usually use the hypothesis-driven to have the conclusion. Okay, when you learn the mathematics, you learn things one theorem to the other theorems. Then you can use the previous theorems to have the new theorems. So you use the way we did, that would be the hypothesis-driven. Okay, you have the new findings based on what you have. Okay, what you have already. Okay, but for the other way to look at things would be the data-driven. You do not know what's the rule, what's the finding, or what's the reason is. You look at the data. You look at the large of data, you find out the pattern. Okay, this is the way we say we use the data-driven to do the research or to do the science. Okay, so that would be the data-driven side. We use a large amount of data to discover new things. Okay, so that's you can think about these two ways to have the results. Actually, is two different directions. Okay, one is from known to prove new things. The other way is from the unknown to get the rules. Okay, so there's two directions. There are two directions. Okay, so I think both ways are very important. Okay, we got a lot of training using the hypothesis-driven. Okay, we use what we have know to get the new theorem. Okay, we have a lot of training on that, and now we use what we say the data-driven, like the data mining. If you have taken this course, if you have taken data mining course, for data mining is actually use the data-driven. Okay, you mine the data, you can find the patterns, the rules from the data set. Okay, that would be the data-driven approach. Okay, these two approaches will be, I think, it'll be equally important. Okay, it would be better that you can use the data-driven to find out the pattern, the rules, and you can use hypothesis-driven to prove it. That would be perfect. Okay, or you can. I think most of the time we use the hypothesis-driven to have the new theorem, to have the new conclusions. We use data-driven to illustrate or to show our finding is correct. Okay, so I think these two approaches are important, okay, to each other. Okay, but most of the time, nowadays I think people use data-driven a lot, in particular for the deep learning. In many cases, we do not know reasons, but we can find it is better for the deep learning model. So that would be the data-driven approach. Okay, the two approaches. Okay. All right, so here's another thing I would like to tell is the genius and the wisdom. Okay. The genius always finds the right answers. Okay. So you always solve the problems and get the right answers. But the wisdom shows that we try to avoid wrong answers. That will be the wisdom. So these two are very different. So we say the genius will be very, very, very smart guy. Okay, he always can. That guy can always have the right answers. Okay, but for the wisdoms, we just try to avoid some wrong answers. Okay, so these two are very different. And the data science belongs to, I think, we would like to have the wisdom instead of the genius. So the wisdoms will come from the experience, general knowledge, or maybe listen to the others, or humility. Okay. So I think the wisdoms basically are the experiences we have. Okay. And most of the models from the machine learning or deep learning is actually use what we say the experience. Okay, to get the wisdoms. So we can apply that to different kind of applications. Okay, so this would be difference between the genius and the wisdom. All right, so in order to do the data science, and now in addition to the coding or to the programming, whenever we have the we might want to look more into the data set, into the data you get. So you might ask yourself some questions. Okay. So for the programmer, I think we just implement it. Sometimes we do not encourage them to ask questions. Okay. But for the data science, things are very different. Okay. You need to think about more when you get the data. Okay, so now you need to practice yourself to ask good questions. Okay, you may say, why people have such data sets? Okay, something like that. Okay, so here's another things about the genius and wisdom. Wisdom, yeah, I think. So, yeah, that relates to that. But anyway, so I think everyone uses Google, right? Google is actually the search engine. The search engine. We try to search things. Use search engine. As the technology changes, and if we would like to use our the wisdoms, I think we might have in the future what we call a prediction engine. Okay, we can use what we have before to predict something in the future. Okay. So in addition to the search engine, we just try to find out something. We might, and maybe later on, maybe we might have what we say the prediction engine. We try to predict things. But actually, if you do the machine learning, I think you do a lot of predictions. So we're getting much closer to a prediction engine. Okay, so this just like the magic mirror versus the crystal ball. Okay. Like this, the search engine is like a magic mirrors. Okay, who will be the most beautiful women in the world? So you get the answer. You search it, right? You will get the answer. And the crystal ball try to have some fortune teller. Okay, you can predict things. So I think in the future, we might have the prediction engine. We can predict things. Okay, so now if you try to working on the data science, in addition to the hacking skills, programming skills, you need more curiosity, okay, on the data set. So you need to develop a curiosity about things, okay? Okay. This is very important, okay? Otherwise, you just program. You just feed the data in and get the data out, and that's it, okay? All right, so try to develop in curiosity. Okay, and keep enthusiasm on explore information from data set. Okay, and it would be better that you have wide-ranging interest. Okay, you may have interest in many things. That would be good. Okay, and as I mentioned, try to practice. Ask yourself some questions. Okay, the 5 Ws I think you have learned before. We usually use this to ask problems, okay? So now if you have the data set, you might ask, who have this data set? And what the data set is? And where I can get the data set? Or when the data set is ready? Or why people use that data set? Okay, so you might think about maybe more. But the 5W will be the basic. And you can practice, ask yourself some questions. Okay. Okay, here, these are 4 data sets you can refer to and try to ask yourself some questions if you want. You can practice by yourself or you can practice with your classmates. Okay, and we might have the data sets like the baseball reference. Okay, this will be the Major League Baseball. Or we have the movie database. So you can go to the website to check and try to ask questions about the data set they provide. Okay, just for your reference. Okay, so right. So now I think we know what the data science is. and what's the relation between the big data and data science. Okay, I think when you do the data science, you might have the problems about the big data. Okay, that's, I think, first of all, I would like to distinguish between these two. Okay, and from the terms, for the big data, it has its own definition on that. We might talk that a little bit. Okay, and the way to manipulate, to process the big data could be part of the data science. Okay, and so the data science, we will have some method to analyze massive amount of data. Okay, but the data science also have the techniques for small data, Okay. All right, so the big data actually have some problem because when the amount of data is getting larger, some traditional data manager approach cannot be applied to that. So some new way or new architectures will be provided to process such amount of data. Okay, so now let's introduce a little bit about the big data. Okay, you heard about the big data. So the first impressions about the big data is, you will say that the amount of data is pretty big, right? Okay, actually, this is the first V, the value. The value, that means the size of the data could be huge. Okay, 5 Vs. Okay, this will be the first V for big data. The second properties would be the velocity. That means the speed at which the data is generated. So the data will be generated quickly and change quickly. Okay, so the second one will be the velocity. Okay, that also means that the data, the value of the data will change with time. Okay, that will be the second V. The third V would be variety. Okay, as I mentioned in the previous class, in the current IoT environment, the data we get could be different type of data. So we might have heterogeneous data. So that would be the variety. So we'll need to manipulate the data with different types simultaneously. Okay. All right, that would be the third V. The fourth V will be velocity. Okay, that means that relates to the data we consider may have the errors. Okay, that kind of data we call it like the uncertain data. Okay, the data we get maybe have errors. Or maybe inaccurate, or incomplete, or that be the fake data. Okay, that belongs to the veracity. Okay, so it's something like, can you trust the data you get from the internet? It's a big problem, right? We must be very careful about the data we get from the internet. Okay, it could be fake. Okay, the data could be not real. Okay, so that could be one part. But for the veracity, it includes that the trustworthiness or the data accuracy. Okay. I think most of people working on the data for the big size data, data with velocity, or they manipulate different type of data simultaneously. And that's lays work on the veracity. Okay. But anyway, for the 5V of big data, it includes the volume, velocity, variety, and veracity. Veracity, okay, variety, okay. All right, so the last V would be the value. That's what I mentioned in last class. We should make the data valuable, okay. We will try to make a valuable data, okay. Otherwise, it is useless, okay. All right, so we need to turn the data into values, okay. That's very important. Otherwise, we don't need to look at the data, right? Okay. We want to get something from the data. All right, so this will be the 5V of big data. Okay. Okay, so, but for data sets, not every big data set have this 5V simultaneously, okay. In many cases, we will have the data sets have maybe 2 or 3 V's properties in the data set, okay? So we might have the large amount of data, and the data will change with time, okay? But the data will be homogeneous. So most of the case, the big data we face or we manipulate may not have the 5 V's at the same time, okay? So if you do the work on the data set have 2 or 3 V's, you can say you are working on big data problem, okay? Okay, so that's why you may heard that someone do the big data problems, but you realize the data set is very small. Okay, but they also say we are doing the big data problem. Or that could be they are working on the data veracity and the data velocity. Okay, they try to process the data change, the value, they try to process the data with the velocity. That means the data can change with the time, okay? And they manipulate the data with multiple types. Okay, so whenever you do the work on a data set with 2 or 3 V's, you can say you are working on big data, okay? Not necessary to have a large amount of data. Okay, so these two, big data and data science, would not be the same. But they are something in common. Okay, so it is hard to say. And as I mentioned, that actually for the data science, it also can be done on small data sets. Okay, so there's an intersection. Or we say the overlap of these two areas. Okay. For the big data, there are some technology belongs to the big data that may not belongs to the data science. Okay, so there could be an overlap. All right, so here's a table that tells about the data science or data analysis and software delivery. Okay, the programmer, I think. Okay, so this would be traditional analysis, software delivery, and data science. Okay, here are some the tools with these 3 different roles. Okay, so for the traditional analysis, they will use the SAS or R or Excel or SQL, something like that. For the software deliveries, we might use programming language, okay, or the project management. And if you look at this one, for the data science, it might include both, okay, or more, okay. So there are some tools, not only in these two, respectively. Okay, so there's a table that shows the difference between these three rows. Okay, use the tool they use or the method they use. Okay, so this will be the traditional analysis, I think, and because for the software delivery, they do not need an analysis method, so there will be nothing here. But for the data science, we might employ more method for analysis, like clustering classification that you have learned from data mining, or some models from machine learning or deep learning. Okay, so you might see this, the data science here could be the union of these two, more than the union of these two. Okay, more than the union of these two. Okay, and they just show the difference, and you know what the data science will be. Okay, so here just gives some difference between different topic or different fields. Okay, this will be the scientific modeling, and this will be the data-driven approach. Okay, so this part actually try to do the calculation. Okay, try to use what we say the physical-based models. Okay, and I think this part may belongs to what we call the hypothesis-driven approach. We just do the calculation to derive the results. And here is the data-driven approach. Okay, that's different. Okay, from that says the data science will be different, a little bit different from the scientific computing. In the data science, we use the data-driven approach. Okay, data-driven approach. Okay. And the machine learning and data science, actually, in the data science, we might use the models from machine learning, in order to do the analysis job. Okay, so for the machine learning, I think some of you are good at this part. Okay, you know lots of the models from machine learning, and there could be lots of mathematical properties. Okay, and it would be better that we can have the paper published in machine learning. Okay, and for the data science, we try to look at things. We try to find out things. So we simply try to take actions on that. Okay, not only for the paper publications, we might do something practically for the data science. Okay, and this one actually try to compare the data science and the data engineering. I think most of the computer scientists earlier or in the previous time, most of the people from the computer science do the data engineering job. Okay, and I think in the last class we have I have give you some idea about what's the data engineering and data analysis and data science. Okay, here just give you the table that show you the difference between these two, between the data science and data engineering. Okay. Okay, so the approach will be different. Okay, for the data engineer, we try to implement these things. For the data science, we try to explore things from the data set. Okay, the approach will be different. And if you look at this one, the data science, okay, for the data engineer, a bachelor or a master would be good enough, okay, or be trained, that's fine. For data science, more is better for the educations. Okay. PhDs is common, so I don't know, maybe it will be an encouragement for you to study more. Anyway. Okay, so here I would like to indicate would be the presentation skill. Okay. Most of the computer scientists will not do the presentation. Like the data engineer, presentation is not important. We just like to have the system work, and that's it. Okay, let the machine talk. Okay, so we usually do not care about the presentation. But for the data science, presentation skills are important. So this is why we have 2 presentations for your term project. Okay. So this is very, very basic skills for the data scientist. Okay, presentation skill. Okay, and for the data science, the programming skill is not as important as the data engineering. For the data engineering, the programming skill is very important. Okay, because the data engineers need to work on the system, so that would be an important skill for that. Okay. All right. So here just a comparison between the data science and data engineering. All right, so this will be the data science applications. You might see a lot. In business or healthcare, the urban living. I think in addition to this, I think you might see more applications. But one important thing is if you have some background about the data science, I think you can do many things individually. Or you can do the analysis job or do the data explorations by yourself. Okay, this is not common previously because we might ask the other to do the analysis job for us, maybe a group or team, they can do the data analysis job. But if you have some background about or you know some tools about the data science, you can do that individually. You can do that on your own. So you can have your, you can implement or you can do the analysis job by yourself. Okay, you don't need to rely on the others. Okay, so that could be very important, I think. Okay, you got the skills, so you can do the analysis job by yourself. Okay, I think maybe 10 years ago, something, if you want to know or you want to explore the data sets, you might refer to the others, or you need to ask the other people to help you. But if you have the background about the data science, I think you can do that by yourself now. Okay, that would be very helpful. Okay, this will be some practical applications that you can refer to. Okay, business, healthcare, or what? Urban living. Okay, smart city, something like that. Anyway, that's just for your reference. And here is one sentence I would like to give you that when we talk about the big data and the data science, I think this sentence is good for the description. If the big data is the product of the IoT, data science will be its soul. Okay. So if you can know what the sentence is, or you can know what the sentence says, I think you have the idea about what the data science is. Okay. All right, let's just give you another case study. That's the customer analytics. That belongs to the business applications, okay? You can have the idea or you can have the data from the customers, and you can do the analysis. You can know some behavior about the customers, so you can have some better way to increase your earnings, okay? Okay, so I think I quickly give the overview on the data science. I think this will be a major part of today's lecture. Okay. Any questions? No questions. Good. Okay, so if there's no questions, I will stop here today. And we move on to the next topics next week. Okay? Good. All right, see you on next Wednesday.